Welcome to the RAOB program's Severe Weather Diagram. The following examples are only available with the optional Analytic module. We have opened the sample sounding with the standard SKU-T diagram view. To see the Severe Weather Diagram, we'll use the Displays menu, then select the Severe Weather option. Note that you can configure RAOB to automatically open with this diagram by using the Options menu, then select Program Options, and then choose the Severe Weather view, and then close. And the next time you open RAOB, this Severe Weather Diagram will be initially displayed. Before discussing the four nomograms along the left side of the screen, notice that this sounding contains high CAPE values, quarter-inch hail, and large sweat values. And also note the RPM value located at the bottom of this list, because it will be mentioned later in the video. So let's overlay some thermodynamic graphics to see why these parameters are so high. We'll do this by opening the toolbar and then apply the significant levels, lift parcel, and CAPE displays. And as you can see, this is a very impressive sounding with lots of convective potential. Okay, let's now close the toolbar and erase the graphic overlays with the refresh option. And to better study the nomogram features, let's open the Diagram Options panel with a right click. Select the Pressure and Temperature tab and drop the upper millibar limit to 400 millibars. And then apply. Now we have an expanded view of the sounding's lower layers and can better see its thermodynamic properties and potential. Okay, so now we'll first look at the hail nomogram. It shows that hail is probable with this sounding, and as with any of RAOB's nomograms and similar graphic presentations, you can always obtain extra information with a right click of the mouse. So let's give it a try. In this case, it provides a text message indicating the actual cloud depth ratio and freezing level data used to construct this nomogram. So to better study this graph, let's add the freezing line to the sounding diagram. We'll recall the toolbar with a right click and then select the freezing line option. And now we can see how the freezing line relates to the nomogram and the sounding. And when we alter the sounding data, which raises the freezing level, we move the hail indicator into the no hail category. So let's do that again. And now let's undo these changes with the Restore option and use the Refresh option to erase the toolbar's freezing line. Now let's look at the storm character nomogram. It shows that multicells and/or supercells are possible. And when we right-click on the nomogram, it shows the exact data used to construct this diagram. Since CAPE is an input parameter, let's alter the surface temperature and see what happens. When we increase the temperature, the storm character indicator rises. And when we decrease the surface temperature, the indicator drops into the weaker thunderstorm categories as expected. Even changes to the dew point temperature can produce significant nomogram changes. So let's now reset the nomogram with the Restore option. Now let's look at the dry microburst potential nomogram. It shows that the sounding is too stable for upper level thunderstorms. So we'll right click on the nomogram and it shows the exact data used for diagram creation. But note that this nomogram is mainly intended for really high level environments because the upper level instability index, or ULII, is a function of the 500 millibar lifted parcel with respect to the 400 and 300 millibar temperatures. So, since the nomogram says the sounding is too stable for dry microburst, we'll just make the 500 millibar level more unstable by increasing its temperature. And watch the nomogram indicator move into the gusty potential region. And since the nomogram's y-axis is a function of 700 millibar moisture, will introduce a 700 millibar dry intrusion. And now watch the dry microburst potential get even more gusty. And when we increase the moisture, the potential correspondingly drops. Okay, let's reset this nomogram with the restore option. Now let's look at the last diagram, the storm category nomogram. It shows that this sounding is a strong candidate for thunderstorms. In fact, this nomogram is the most important diagram on this screen. Specifically, the RPM value, which is listed just below the storm category title and shows a value of 65%, is the same RPM value seen at the bottom of the sounding's parameter listing. RPM stands for RAOB parameter metric and is used throughout the RAOB program. It's very important to note that the storm category nomogram not only consolidates the key parameters from the above three nomograms and the indices listed in this parameter listing, but it also consolidates 40 other key thermodynamic parameters and indices produced by the RAOB program. And while this storm category nomogram consolidates all these parameters into one graphic view, the RPM value defines this graphic as a single numeric indicator. In essence, this RPM value says that 65% of all severe weather indicators for this sounding fall into the strong category. And there's more to this nomogram, much more. Just right-click, and now you see a list of all the severe weather parameters that make up this nomogram and the RPM value. And if you further click on this Configure button, you'll then see how you can individually configure each parameter according to regional and seasonal conditions. To see the details of these special configuration options and displays, you should view the video called the Severe Weather Parameter Configuration Table, which is available at the web link listed at the end of this video or on YouTube. So while this severe weather diagram is a convenient format to graphically analyze convective soundings, the RPM value, or RAOB parameter metric, is a consolidated, all-inclusive numeric value representing the total severe weather potential of any sounding, and it is totally user configurable. Also note that this RPM value can be displayed on any sounding diagram, included in printed listings, exported to external files, and even plotted on cross-sections and time-height diagrams in a meteogram format. And that completes the severe weather diagram demonstration. Thank you for watching.